All right, let's look at this circle. We have a circle with radius 5 centered at 5, 2. So let's open up the Cartesian plane. So my x value is 5. That's 1, 2, 3, 4, 5. My y value is 2. Right, that's the center of the circle. And my radius is going to be 5. So if I went up 5, I'd end up at 7. If I went to the left 5, I'd end up there. If I went down 5, I'd end up at -3. If I went to the right 5, 5, 6, 7, 8, 9, 10, I'd end up somewhere there. So horrible at art, but this gives us a rough idea of what the circle is going to look like. So the equation of the circle, right? All the points on this dotted line are of a form xy. And the relationship between all these xy values is x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared is equal to r squared, right? This is just, we got this from the Pythagorean theorem, right? Because all of these points are equal distant away from that center, right? That line is the same thing as that line, or at least the same length as that line. And all of these points on this circle satisfy this equation. So let's apply this equation to our specific problem. We have x minus the x coordinate of our center is 5. Y minus the y coordinate of our center is 2. And my radius is 5. All right, so all of these points right here, all of the points on the circle, all of these xy points are going to satisfy that equation. Let's give ourselves some more space. X minus 5 squared plus y minus 2 squared is equal to 5 squared. So one thing that we could ask ourselves is, where do I cross my axes? What's my y-axis intercepts and my x-axis intercepts? So let me clear off the page so far. Right, I want to ask myself, where do I cross? Here. Where do I cross my x-axis? Here and here. Right, the way that I drew the picture, we know that we're looking for one y-intercept and we're looking for 2 x-intercepts. So let's show that the algebra actually gives us that. Now, what's true about my y-axis? Right, that y-axis, my x value is 0. So if I'm looking for this y-intercept right there, I should let my x value be 0 inside my equation and figure out what y has to be. So when I let, in fact, let's label this. I'm working on my y-intercepts right now. If I let my x value be 0, it's going to tell me what the y value is. Right? Y is the only thing that's missing. Let's solve for it. 0 minus 5 is -5. -5 squared is 25. I then subtract 25 from both sides. I find that y minus 2 squared is equal to 0. I take the square root and find that y minus 2 is equal to plus or minus the square root of 0. But the square root of 0 is just 0, and 0 plus or minus is the same thing. It's 0. So y minus 2 is equal to 0. I add 2 to both sides, and I get that y is equal to 2. And that makes sense to our picture. Right? That y value is the y value of 2. Now let's find our x-intercepts. Now in the same way, what's true about your x-axis? Right? At this x-axis, your y value is 0. So let's go to our equation and replace y with 0. So the equation, in fact, let's label this x-intercepts. The equation was x minus 5 squared plus y minus 2 squared is equal to 25. I'm looking for the x. My y is 0. All right, let's chase the algebra. I'm looking for x is equal to something. I'm not ready to deal with that just yet, but 0 minus 2 is minus 2, and minus 2 squared is 4. If I subtract 4 from both sides, I find that x minus 5 squared is equal to 21. I then take the square root of both sides and find that x minus 5 is equal to plus or minus the square root of 21. Now, that's going to be a real number. It's not going to be a nice number. It's not going to give me an integer, but it is going to be a real number. And now the last step to do is to add 5 to both sides. So x is equal to 5 plus or minus the square root of 21. So back up to this picture. This x value right there is x plus the square root of 21. And this x-intercept right there is, oops, I'm sorry, not x minus or x plus. 5 plus square root 21 and 5 minus square root 21.